So please welcome Dr. Paul Hessburg up with a big round of applause.
Thanks for having me here. It's really good to be with you. No place to set my coffee. How are you all doing this morning? How are you all doing this morning? Appreciate that. All right, I'm going to talk to you today about a fairly difficult topic, but it's one we need to embrace, and we've been talking about it for quite a few years. For many of us in research and development, we've been looking at this for over 40 years. And the time is now. It's go time for the Wenatchee Valley to be able to take a lot of this stuff seriously. Before I get into the nitty-gritty details, I want to give you some deep time historical context. Before we started putting out fires, we've been doing that for like 6 generations right now. People were burning the North American landscape 40 to 80 million acres a year intentionally so they could live safely on the landscape. So our indigenous folks were master burners for horticultural reasons and for living safely on the landscape. For 10,000 years, they coupled lightning-ignited fires with intentionally burned fires in order to enhance food and forage production, but also to live safely on the landscape. They created habitat for almost everything that they foraged, including big game animals. So there were a ton of open canopy forest in that time, and there were also a lot of meadows. Wet and dry meadows, shrublands were abundant, open canopy woodlands, savannas, that sort of thing. Tons of wetlands, trees are pumps, they dewater the landscape, and so when you have a lot of open forest, you have a lot of wetland across the landscape. Often 40 to 50% of any large landscape was burned or recovering after fires, and that shows you the fire deficit that we're living in the middle of right now. That's what it took to live safely on that landscape. Non-forest areas that I'm going to refer to throughout the presentation, they're wet and dry meadows, they're shrublands, they're open savannas, they're tall and short grass prairies. And one of the reasons why these were so important is because the grocery store was there. When they opened up forests have more snowpack and that sort of thing available to them. When they opened them up, sunlight hit the ground, and that allowed abundant resources in an open canopy forest. It was the grocery store for horticultural foods, material resources, that sort of thing. Before trapping, there were tens of millions of beaver across the landscape. Some estimates are more than 600 million across North America. 600 million, and they were creating vast wetlands. And what that did is it stopped the flow of fire as well. But we've ditched and drained so much of that now, so the loss of wetlands is tied to the modern wildfire problem. These factors together controlled fire severities and their sizes. They're like key levers on what controls the behavior of fire, all right? So the idea that humans lived without fire for most of human time is contrary to history and it's contrary to fact. We're doing it, and we have created for ourselves a significant problem which we need to deal with. So today there's a huge fire deficit. Imagine that the lower 48 states were completely burned wall to wall on about a 30-year rotation. There was that much fire. So an area equivalent to the whole CONUS burned about every 30 years. That's how much fire. It was maintenance fire. It was keeping the fuels low. So when fire came, people didn't worry that there was fire. It was essentially cleaning up slash. It was cleaning up needles, branches, that sort of thing. All right, what changed? So there's reduced indigenous burning. Most of the tribes are on reservations or dead by 1850s, all right? And so the loss of fire starts with the loss of our indigenous people. There's really good anthropological and ecological research to show that this is the case. The first wave of mortality, 80 or 90% of our indigenous population was killed by European diseases. Travers and Traeger started to introduce those sorts of things, but over time, tribes, family groups, the depredation was to a remnant of those people early in the 20th century. They were dispossessed of their lands, and so they were no longer connected to be able to do that burning. We came along, we drained the wetlands, livestock grazing, ate the grasses, that had been the conveyor belts for spreading fires across much of the landscape during that period of time. We built environments. We didn't want fire around them once we developed them. And fire suppression is actually only the last layer on the equation. So we've been keeping fires out of the woods for 150 to 170 years, and a lot of trees have grown in during that time. All right, first wave of logging, we built the West on large trees. In fact, the more fiber in the log, the better. So the first thing we did was cut the large trees. And what happened as we combed through the woods and took the largest trees, shade-tolerant, shade-loving trees filled in the gaps between the large trees that were taken out of the woods. And in many places, between 10 and 100 times more trees are on the landscape from that open canopy condition today. So we really have an epidemic of trees on our forest landscape compared to their native forest ecology and fire ecology. We killed off the hardwoods. They're moist areas and they tend to stop the flow of fire. So aspen forests, birch forests, willows, those kinds of things are riparian areas. They were critical to slowing the flow of fire. With that increased density, tree-killing bark beetles started thinning out the forest. You've seen it everywhere, driving through Blewett. So many dead trees, they hit the ground. They're fuel within 15 or 20 years after they're killed by bark beetles. And the fuel loads are massive as a result of that overstocking of trees. Climate change, it's warmer, it's drier. There are longer fire seasons, hot, dry, windy. And we are us, people. We've changed the fire regime by introducing about 80 to 90% of the fire starts every year. So essentially you've got a powder keg and we're lighting the woods on fire just by not being aware of our surroundings. All right, smoke management. We don't want smoke. In fact, we're exhausted by smoke. But one of the problems is the less prescribed burning we do, the more severe wildfire. Fires are larger, they're more intense as a result. And that's a positive feedback to more severe fire. So we have to figure out how to manage the smoke situation, the human health situation. There are many dimensions of that. You're going to hear a talk about that later on. But we also have to solve the fuel problem and the fire behavior problem. I wanted to show you really quickly what landscapes look like. This is looking out the back of Mission Ridge Ski Area. The top photo is 1930s. The open canopied forest patches that you see are south aspects and ridges staring out of that photo. Below is like a 2013 photo, I believe. These are taken by John Marshall, and you can see how much the forest has filled in less than 100 years. So these are examples of pine forests or pine forest mixed with Douglas fir. They're our driest conifer forests, and we have a lot of them. So they usually had frequent fires every 20 years or less. So 5 to 20 years would be an average fire frequency. We had some moderate severity fire as well. Low is less than 20% get killed. Moderate is 20 to 50% get killed. And here's why those fires were so important. On the top photo, you can see frequent fires thinning out the dead wood and getting what are called the fuel ladders, layered canopy that can take fire up to the tall trees. And what it did is it repeated a similar condition over time. So frequent fires begot lower severity fire over time. And that was an important stabilizing influence. So this basically said at a local level, if you keep it open and patchy and gappy like that, it's likely it'll stay that way and it'll burn that way again. So it's a stabilizer. Lacking these fires, what happens is the forests get denser, which is the problem we have today. And that forest density can take the flames from the dead wood on the ground up to these fuel ladders into the canopy, resulting in fires that are not characteristic of these forest types. So that's why we're seeing so many crown fires. We changed the density and the structure and the composition of the forest in a fair period of time. And those change agents that I talked about are together the vehicles that got us there. All right, so now we have a lot of crown fires across the landscape, and that's an anomaly for these dry forests. This is a little further up in the elevation, and these would be moist mixed conifer forests. So think western larch, Douglas fir, lodgepole pine, those kinds of conditions. And the top photo, again, from the 30s, via from the National Archives, black and whites. These are moderate frequency fires because the growing season starts later, ends earlier in these environments, and so fires aren't as frequent. And it's because the fuels aren't available to burn many years. And this patchwork is what you would typically see in these moist mixed conifer forests. The patchwork was made of open and closed canopy conditions, on very density conditions, and quite a bit of non-forest. And in less than 80 years, down below, you can see a carpet of trees. That's Mount Rainier in the top right of both of those photos. And this is on the Wenatchee Ranger District. So these landscapes had all three flavors of fire: low, moderate, and high severity fire, and they were sculpting patterns that were the governors, the levers on fire behavior over time. All right, and even in our cold forests, we think of the cold forest, lodgepole pine, subalpine fir, Engelmann spruce. These are in elevations from 6,500 at 9,000 feet. We think of them as being dense carpets of trees, but they weren't. At any one time, 30 to 60% wasn't in forest at any one time. And the reason why is these forests burn so readily. They're on the tops of mountains where lightning is striking. So fires are coming off the top of the hill and then burning so much of it. And this patchiness is what allows the rest of the cold forest to be cold forest. All right. And now we've got, like you see in the bottom photo, and so there's a continuous carpet of trees that can convey fires. So no matter where you are in the landscape, different kinds of changes add up to a more flammable landscape. And there's stuff we can do about it. Alrighty. So these non-forest elements are critical to resilient landscapes, and there was a lot of it. In a lot of landscapes, we see 30 to almost 60% of the area that's capable of growing forest not in forest at any one time under the historical fire regime. And that provides, so that the picture on the right is what a typical forest looked like before European settlement. All right. A lot. And this takes you from the valley floor to up in the high elevation. So dry forest down low, riparian areas, that sort of thing. So an awful lot of non-forest on these forest-capable sites. Those were the kinds that I talked about before. Depending on where you are, in which region you're in, it was 25 to 70% of the landscape. 40 is a pretty good average for most ecoregions, really dependent upon the geography. Once again, these are the non-forest conditions. And if you stop and think about it, having a salad bowl of ingredients like this plus forest ACE classes is a fantastic way to create habitats for a lot of critters that are trying to make a living on that landscape in fairly close proximity. So forests weren't just forests, they were non-forests as well, and that's part of the resilience recipe. All right. These features together limited fire rate of spread, fire size, and the intensity of fires. Surface fuels were typically grasses and shrubs, and here's a key idea about that. Grasses and shrubs are available to burn in the spring and all the way through most fire seasons, but they also recover their moisture because a relative humidity change is NICUS. So fires go to die in the evening when they run into grass and shrub areas. So that's the governing influence of them. They're always available to burn by day after 10 o'clock, but fires go out in the evening when the sun goes down behind the hills, that sort of thing. So they're governors on spread. And you think because they're grasses, they're flashy and they're always going to burn. But the opposite is true for half the day. This is a big thing that's changing right now with climate change. We're having about 6 weeks a year where relative humidity doesn't recover. That's deeply concerning. So these fuels rapidly cure. They spread fast fire, but they're short flames. It's very low intensity. So when the flames get to the edge of most forest types, they don't start a fire. So that's another sort of governing factor of these. So the cartoon is this. There's a tug of war between factors that are growing forest, the sunlight that comes in, the moisture, all of that sort of stuff, those biophysical conditions across the landscape. But many of them are the same factors that drive the fire regime. So it's a tug of war between forests growing, a really high potential energy state, and the same kinds of factors during the fire season trying to take away forest. And what you see is the emergent property is these hardwood forests, these non-forest elements, and they're all governors on how fires get to behave on the landscape. So you reach a set point, and under climate change, we can reach another set point, all right? So these non-forest hardwood elements, they emerge from that tug of war, and they're critical for resilience going forward. the climate change, our modeling shows us this intensifies. And what that means is there will be more non-forest elements if we even if we create good transitions, and there's going to be more open canopy forest. So it's wise to move in that direction. So this little movie is showing you how fires interact over space and time and how they stabilize conditions across the landscape. On the left side, you can see the aging of forest structure. The darker the green, the older the forest condition. On the right, you can see open versus closed canopy conditions. The lighter the green, the more open, the darker, the more closed the canopy conditions are. And so this is actually running the fires in eastern Washington across a big landscape area, the fires that were all put out. We ran them and we modeled them, and this is the kind of landscape that would have emerged across space and time. So you can see that fires govern fires over space and time. They're eliminating fuel, they're eliminating the ability for fires to be conveyed across that landscape. So this reburning is critical. You can store more forest on the landscape because of what the first fire will kill trees. The second fire that follows it, it'll be overlapped by another fire that burns the dead wood, and it disconnects the dead wood on the ground, the surface fuels, from the developing canopy. And what we're learning in our work is that you can store more forest if you have reburning on the landscape. So it's not just getting fire back in, but it's maintaining this culture of reburning, and that's what our indigenous people learned. Alrighty. So we're also learning that hardwood forests are really important elements on the landscape. They're governors to fire spread, and so we've actually attacked hardwood forests in favor of conifer fiber because the money trees are conifers and hardwoods. We started to develop an economy when we had primary hardwood forests, but once we got rid of them, now we herbicide them. And so we can grow conifers. We plant conifers, we kill the hardwoods. Having hardwoods back on the landscape is another critical governor on that landscape. Climate warming. This is actually a core message. Right now, there's a really tight linkage between how much area is burned every year and the warming. Okay, so acres burned is tied to the warming, hot, dry, windy. But the indigenous burning gives us optimism. It's basically saying that if you do the burning, you can weaken the connection profoundly. All right. And here is a, whoops. This is an ooh and ah moment, please. We are seeing drawings that are animate identical, right? So on top, this is the effect of indigenous burning. You can see the hardwood elements, a lot of open canopy forest. These are elevations from, say, 1,500 feet in elevation all the way up to probably 7,500 in the high country. What the drawing on the top is saying, they're burning somewhere on the landscape all of the time. So you see the yellows and oranges, the hardwood forest components are actually more abundant. We start putting fires out after the 10 a.m. rule, which is between 1934 and 35. And the climate helped us a ton at that. And so you can see we're dousing fires and we're thinking we're amazing at fire suppression for about 50 years, until about 1985. And what we've created is a denser forest condition with fires that look like that on the bottom, in terms of their smoke production, in terms of the area burn. All right, what's going on with the climate? This is what's going on with the climate. These primary greenhouse gases right here are increasing in an uncharacteristic way on the landscape. The graph on the right is showing you the effect of that. So in the middle period, when the climate is unsettled, that period is used as a baseline to determine how the global average from the mid-20th century is increasing in temperatures right now. So it's essentially tied to this in space and time. There are differences by climatic region, but by and large, the climate is warming significantly and the warming is accelerating, and wildfires are increasing the warming. To give you an example, British Columbia, 3 of the last 5 years has had so much wildfire smoke that their smoke, Canada-wide, increases emissions from all other factors at country level. So from the Nunavut territories down, burning is changing the climate of Canada at an accelerating rate, for example. All right, and this is the cartoon of what's going on in the 21st century. Summers are growing by 2100, they'll be 6 months long. That's pinching out spring and fall seasons. and it's washing the winter, it's squeezing the winter out. So the amount of time for precipitation is going to get less in terms of the snowpack. It's going to leave faster, and so summer is going to start earlier. And this is predicted for the entire northern hemisphere. All right, we're actually in a better position than further north because the polar ice is really important at regulating that climate. It's tripling, it's warming at triple the rate of Wenatchee right now in Canada and in the north. All right. So what can we do towards climate and wildfire resilience? Our conifer biomass in the forest is unsustainable. We want to store carbon in it, but the fire regime says you can't store carbon like that. So it's between 40 and 50% of the forest density and cover that we have is unsustainable. And wildfires are regulating that tug of war right now. So we need to stabilize that tug of war. Some of the elements I talked about that you can add back. And with climate change, these non-forest conditions and open canopy forest conditions favor reduced fire threat. So doing that thinning and burning is a good idea, bringing back hardwood forests, and we'll see more water released, more water available, more wetlands occur in forested regions. What are the takeaways for the built environment? Adopt the WUI code, all of it. It's not a cafeteria menu. The WUI code is meant to work together to keep communities safe. In most communities right now are shopping the WUI code, the stuff that they like, the stuff that allows economic revenue to burgeon, but the problem is it's actually enhancing some of the problems. So take a look at the US or the International WUI code. They're really robust. Communities need to adopt them. Allied to that is doing the Firewise information for your houses. Also not a cafeteria. If you want to be safe, you can't shop it. Those things are meant to work together to keep homes safe. Community-wide protection planning is critical. I believe we have them, but we're reticent to go whole hog on those. Most communities are having one, but protection planning is a multifaceted thing. And again, those things work together to be able to produce safe communities. Avoid high fire danger environments for development. We're creating problems that we can't fix right now. Single road access to a community basically means that firefighters are going to have difficulty protecting their homes. Separate egress roads are going to be essential. Firewising your property, and as a small village or community, making sure that you're all protected because we're burning each other out. All right. There's a lot of disadvantaged folks. Smoke's going to be an issue. It's going to be an ongoing issue. So have emergency shelters. Find out where the disadvantaged people are who don't have capacity. Build safe places. Those kinds of things. You're going to hear more about that. All right. In terms of sustainable recreation and just living, we're seeing more areas convert to non-natives. A lot of these are fire promoters across the landscape. It's the elephant in the room, right? And so I think we have an opportunity to be able to protect our foothills and dry forests. And that's the sweet spot for the Wenatchee Valley. The entire Wenatchee Valley is in very dangerous condition right now. It's go time for us to start protecting our communities and our homes. We will burn each other out without it, right? I know that's not a popular thing to say, but it's go time for us right now. We've wasted quite a bit of time. We're going to have to be experimental in the things we try. For me, I know this is my first climate change. Us. First climate change, yeah. So we don't know everything we need to know. We got to try stuff. We got to figure stuff out. Figure out what works, keep doing what works. Stop doing stupid stuff that doesn't work, right? So we're going to have to be experimental. We're going to have to say, what are people trying? What's working? Who has communities like us? So experimental sheep and goat grazing is now coming out. And I think this is a credible thing for us to explore on both sides of the river because it's going to be our sharp step that's going to send fire into our communities. So getting the homes and the neighborhoods ready is critical, but also change the way fire comes to us. We have a history of grazing in the United States that's just crack, okay? But we're learning how to graze better, and it requires herd management, following the green up in the foothills, having herders who are moving electric fences and bunking critters and managing the stubble height on the grasses so you don't overgraze it. So follow the grain up, those kinds of things. Herd management, really enforcing the quality of grazing on the landscape. Alrighty. So in terms of things that are important to our community, shrub stuff is very vulnerable to burning. When it burns, it's going to have more cheatgrass, more non-natives that increase the vulnerability to burning. We're going to live with that. All right. Our dry forests are vulnerable to beetles. Beetles are going to put more fuel on the ground. So opening them up, burning them regularly, getting this reburning action going is critical. And it's also going to be important in near WUI and recreation assets that really matter to us. Expect more extreme drought and more extreme rainfall events. In the Cascade Mountains, many of the watersheds are going to be rain dominated, not snow dominated by 2050. We're modeling that right now each year.
Yeah.
And my talk is over, Edith. All right. How'd we do? Pretty good for time?
C'était top when he met.
What are your question? Do you have access to this? Yes, we're going to send them out later.
No, it's top secret. Yes, we'll have we're adopting sure white
Dory shop. So I think while this is doing its thing, we'll have a few minutes for questions, and we'll try to get that back up. But sorry for that.
It's just
She was super.
How can we reestablish the hardwood trees?
an awful lot of them are early seral species, so the hardwoods have a really different ecology. Sorry, sir. A lot of the hardwoods have a different ecology than conifers do. Reproduction. Some of them are clonal. For example, aspen regenerates from a clonal root system and it sprouts from that root system. But we're also finding that it's prolific cedar, and those seeds are really viable, and we're seeing aspen invade areas that haven't supported aspen for a while. Yeah, I'm not going to fall for that. So in a lot of ways, opening it up and thinning invites aspen where it's been there before. And in areas where you have aspen, opening up canopy conditions invites more spread by seed, for example. Birch is on its way out in eastern Washington and halfway up British Columbia right now. Dieback is in serious trouble, and so it's not one that we can have big expectations from. Willow species, maples, our riparian areas. One of the most important things about historical floodplains is that they stopped fire. And so they're downcut and dewatered now, and conifers occupy our floodplains. Getting the conifers out of those areas and allow hardwood shrubs and trees to be in those areas is a wet blanket to the flow of fire. You've got a lot of creeks and tributaries, that sort of thing. So muscling up in that space is also a good block to fire flow. How are we doing?
We have time for one, maybe two more questions. Any other questions? Yeah, I'll make
This isn't really had to do with the forest. It's more neighborhoods. I'm from Seattle, the other side. And I notice around here, everybody puts up arborvitaes. Or protection from the wind, from the traffic, or whatever. And I hear they can go up so fast that...
They're explosive. They're mostly dead stuff on the inside. All right, and a lot of the spruces, England spruce, Colorado blue spruce, there's so much dead mass. So if you get an ember in that, it goes up like a Roman candle. A lot of the cypress are that way. A lot of the cedars are that way. Not western red cedar so much, because it tosses its old needles. They drop to the ground. But an awful lot of the cypress are troublesome. Off-site spruce that we plant are troublesome. And you'll notice a lot of dieback on subalpine fir. We plant it everywhere in the community. And so now an awful lot of trees have 50% dead branches. That tree wants to live at 5,500 feet in elevation, not at 660 feet of elevation. So yeah, dead conifers away from the house, planting trees. The fire-wise principles and recommendations are really good for how you think about the first 3 feet, 5 feet, 10 feet, 30 feet from the house. And follow those steps, and it increases the likelihood that your house will not burn. There's no risk-free scenario. It just increases the likelihood that communities and homes don't burn.
All right, we're gonna do one more here. I guess I'll finish this up.
So what hardwoods do you recommend planting?
So maples are fantastic. They're actually recommendations for tree species by height class that are really important. And most of the public utilities have those. I can give you, I think, a 1-pager or 2-pager that will show you mature heights of trees. So power lines matter, right? And how you put them, well, they're a big problem for power distribution. So tree height's going to matter. So they vary by tree so the maples are fantastic, including sugar and silver maple that are not native to the area. The elms are fine. Aspen is good. Aspen in the neighborhoods will not get tall, so you have to recycle aspen. It'll die back when it gets to be 35, 40 feet tall. And so that's a problem because the water column breaks because of the hot, dry, windy summer.
And the aspen won't become invasive.
You're going to have to deal with aspen. It suckers like crazy once it develops a clonal root system, so that's the trade-off with it. Yeah. If somebody would like a list of those hardwood species, I can give it to you by the height and that sort of thing. Just send me an email and I'll get it to you. All right? Yep.
Awesome. Thank you so much, Dr. Hessburg. Sorry about that. We've got computers in there.